Hello everyone. Today we will solve numerical problems based on partially filled waveguide. The first one is show that the resonant frequencies of a partially filled rectangular cavity are solutions to the transcendental equation given by kx1 upon epsilon 1 tan kx1 d equals to minus kx2 epsilon 2 tan kx2 a minus d with kx1 square plus n pi by b whole square plus p pi by c whole square is k1 square and kx2 square plus n pi upon b whole square plus p pi upon c whole square is k2 square. So, we will start solving the problem. So, in the question we have partially filled rectangular cavity. Okay. So, partially filled rectangular cavity, we can draw this as so this will be x axis, this is y and it is a rectangular cavity. So, in this we have z. And since this is partially filled, so this is the origin O 0 and then this will be A, this is B. Let us denote this point as D. So, this one is filled with epsilon 2 comma mu 2 and this is epsilon 1 mu 1. Okay. So, this is partially filled rectangular cavity. So, we will have additional conductors covering the z equals to 0 and z equals to c. So, at both the ends we are having at z equals to 0 and z equals to z equals to c, we are having conductors placed. Okay. So, for this we can write the potential functions as, to start with we will start from writing psi 1 T m will be C1 cos of kx1 x sin n pi y by b sin p pi z by c. Similarly, psi 2 T m will be C2 cos of kx2 a minus x sin of n pi y by b sin of p pi z by c. Okay. So, these are the psi functions and now what we will do, we will find out all the fields and then from the continuity equation we will try to find out the transcendental one. Okay. So, we can write E1 as E of y1 will be 1 upon j omega epsilon 1 del square psi upon del x del y. Okay. So, we can write 1 upon j omega epsilon 1 del square upon del x del y. Okay. So, this is psi 1 since it is E y 1. So, in place of psi 1 we will write C1 cos of kx1 x sin n pi y by b sin p pi z by c, which gives us 1 upon j omega epsilon 1 del x of. So, at first we will differentiate with respect to y. Okay. So, it will be C1 cos of kx1 x. So, with respect to y we are differentiating. So, sin n pi y by b, we will have cos n pi y by b and multiplied by n pi by b. So, complete differentiation and then sin of p pi z upon c. Okay. So, then again we will differentiate 1 upon j omega epsilon 1. So, now we will differentiate with respect to x. So, it will be C1. So, cos kx11 x will be minus of sin kx1 x and kx1 cos of n pi y upon b multiplied by n pi by b sin of p pi z upon c. Okay. So, therefore, we get 1 upon j omega epsilon 1. So, there will be one minus sign. So, minus 1 upon j omega epsilon 1 C1 kx1 n pi by b sin of kx1 x cos of n pi y by b sin p pi z upon c. So, this is EY1. Okay. Now, EY2. So, EY2 will be 1 upon j omega epsilon 2 del square psi 2 upon del x del y. So, again in the similar manner we will write 1 upon j omega epsilon 2, this will be del square del x del y. In place of psi 2 we can write C2 cos of kx2 a minus x sin of n pi y upon b sin p pi z upon c. Okay. Now, first we will differentiate this with respect to y. So, we will write 1 upon j omega epsilon 2 del of del x. So, we are differentiating with respect to y. So, first one will remain same. So, C2 cos of kx2 a minus x, okay, and then sin n pi y by b. So, it will be cos of n pi y upon b multiplied by n pi by b and then again sin p pi z upon c. Okay. We can write it 1 upon j omega epsilon 2. So, now we will differentiate the above with respect to x. Okay. So, we will have C2. So, cos of kx2 a minus x will be minus of sin kx2 a minus x multiplied by minus kx2. Okay. cos of n pi y upon b n pi by b sin of p pi z by c. Therefore, we can write E y2 is equal to 1 upon j omega epsilon 2 C2 and C2, then okay, this minus minus gets plus, so C2 kx2, then n pi by b sin of kx2 a minus x cos of n pi y upon b sin of p pi z upon c. So, this is E y2. So, we can give this as equation number 2. Now, E z1. Okay. So, E z1 will be 1 upon j omega epsilon 1 del square psi 1 del x del z. Okay. So, this will be 1 upon j omega epsilon 1 del x of, okay. So, we will differentiate with respect to z. Okay. So, z, so we will have this one as c1 cos of kx1 x sin n pi y upon b. So, with respect to z, so we will have cos p pi z upon c multiplied by p pi upon c. Okay. Now, we will differentiate this with respect to x. So, we will have 1 upon j omega epsilon 1 so this will be c1 so the x with c1, so this will be sin kx1 x. So, this will be minus, okay. This will be kx1, this will be sin n pi y upon b cos p pi z upon c, then p pi by c. Okay. So, therefore, we can write E z1 as minus of 1 upon j omega epsilon 1 c1 kx1 p pi by c sin of kx1 x sin n pi upon b cos of p pi z upon c. So, this is E z1. So, this will give us equation number 3. Now, we will find out E z2. Okay. So, E z2 will be 1 upon j omega epsilon 2 del square psi 2 upon del x del z. Okay. So, that is equal to 1 upon j omega epsilon 2 del x. So, first we will differentiate with respect to z and then with x. So, first is with respect to z. So, we will get C2 cos of kx2 a minus x sin n pi y upon b cos p pi z upon c. So, since we are differentiating with respect to z, so sign will be cos and this will be p pi. So, this is p pi upon c. Okay. Now, this whole thing we will differentiate again with respect to x. So, therefore, 1 upon j omega epsilon 2 with respect to x. So, cos will be minus of sine. So, minus c 2 sine of this will be k x 2 a minus x minus of k x 2 for complete differentiation, and then we have sine of n pi y upon b cos of p pi z upon c, and then p pi upon c. Okay. So, therefore, we can write E z 2 as 1 upon j omega epsilon 2. Okay. So, this minus and this minus will become plus. So, 1 upon j omega epsilon 2, this will be C 2, then k x 2, then from that side we have p pi upon c, and then sine of k x 2 a minus x sine of n pi y upon b cos of p pi z upon c. So, this is E z 2. So, we will give this equation as equation number 4. Therefore, we can write, so now we have E y 1, E y 2, E z 1 and E z 2. Okay. Now, from continuity of field quantities, we can write, so from continuity of field quantities, we can write 1 upon epsilon 1 C 1 k x 1 sin k x 1 d is equal to minus of 1 upon epsilon 2 C 2 k x 2 sin of k x 2 a minus d. That is, we are equating E 1 and E 2, E y 1 and E y 2. Okay. So, we will get this. So, this equation we get from the continuity of field quantities. Now, we will find out h y 1, h y 2, h z 1 and h z 2. Okay. So, we know h y 1, we can write it down like del of psi 1 upon del z. Okay. So, we will have just one differentiation with respect to z. So, we can write it like C 1 cos of k x 1 x sin n pi y upon b cos p pi z upon c, then p pi upon c. Therefore, h y 1 can be written down as, so p pi, this will be p pi c 1 upon c cos of k x1 x sin n pi y upon b cos p pi z upon c. Okay, let us denote this as equation number 6. So, we have now hy1 with us. Now, we will calculate hy2. So, hy2 will be del psi 2 upon del z. So, this will give us c2 cos of k x2 a minus x sin of n pi y upon b cos of p pi z upon c p pi by c. So, therefore, we can write this like, so we have p pi c2 upon c cos of kx2 a minus x sin of n pi y upon b cos of p pi z upon c. So, this is hy2. We will give this as equation 7. So, this is equation number 7. Now, hz1. So, again hz1 is minus of del psi 1 upon del y. Okay. So, that is equals to minus c1 cos of kx1 x cos of n pi y upon b. So, n pi by b sin of p pi z upon c. Therefore, we can write hz1 as minus of n pi c1 upon b cos of k x1 x cos of n y upon b sin of p pi z upon c. So, this is equation 8. Okay. Now, we will find out hz2. Okay. So, hz2 is minus of del psi 2 upon del y. That will give us minus of c2 cos of k x2 a minus x. Okay. So, differentiating with respect to y. So, we will have cos n pi y upon b and then n pi by b. Okay. And then sin p pi z upon c. Okay. So, that we can write down like minus of n pi upon b c2 cos of k x2 a minus x cos of n pi y upon b sin of p pi z upon c. Fine. So, this is hz2. So, we can give this as equation number 9. Okay. So, again from the continuity of field equations we can write So, again from the continuity of filled quantities we can write C1 cos of K x1 d, so at equals to C2 cos of K x2 a minus d, that is at x equals to d we are checking the continuity of the field equations. Okay. So, this is at x equals to d, fine. So, this one again we are getting from the continuity of filled quantities. Okay. Now, we will divide this equation with equation number with this 5. Okay. So, we will divide 5 with this equation and we will have 1 upon epsilon 1 C1 kx1 sin of kx1 d upon C1 cos kx1 d is equal to, there we had minus 1 upon epsilon 2 C2 kx2 sin of kx2 a minus d divided by C2 cos of kx2 a minus d. Okay. So, thus we can see, so C1 will cancel out, this C1, this C1, this C2, C2. Okay. So, we will have kx1 upon epsilon 1. So, sin kx1 d upon cos kx1 d will give us tan kx1 d is equal to, so this is minus, so we will have kx2 upon epsilon 2 tan of again kx2 a minus d. So, thus satisfying the given condition. So, that is all for today. Thank you so much.